area before. However, today there are some things where it gets a little more complicated. First of all, what is surface area? Jackson.
Area of a surface.
Yes, and the surface area here is actually the area of all sides added together. There is not really a magical sort of formula for this. Okay, unfortunately for you, let's say I've got a rectangular prism, looks like this. And again, surface area is the area of all the sides added together. It's like if you had a box that you needed, appropriately enough at this time of the year, to put Christmas paper around. How much Christmas paper, how much Christmas wrap would you need to wrap this box? Okay, so you have to figure out the area of all the sides. Well, we need to figure out how many sides do we have. In this shape here, we have how many sides? Jack? How many sides to any box?
6.
6, okay. You got your 6 sides, okay, and let's label them because that's good to know. Let's say here is our front, right there. And the nice thing about this, if there is a small little nice thing, okay, the front right here is exactly the same as the back side, which you can't see back there. So we've got a front and a back. We have this, which we'll call the right side, which is exactly the same as the left side over here that you can't see much of. And then you have, let's see if we get a different color just and then we have, what's this on there called, Lauren?
The top.
Yeah, we've got a top. Wow, it looks all three-dimensional here, doesn't it? And we've got down here, what else you can't see is the bottom. However you can. Now the book sometimes tells you kind of to rip that shape apart and maybe draw, they call it a net, not a net from the cello, which doesn't make any sense to you because you don't know what that is. But if you had a box, you do. If you had a box, like a cereal box, and you cut like the edges so that you could actually fold it out flat, what would it look like? Well, here's what this thing would look like. Here's my top. It's about this type of rectangle right here. What would be connected to it? That back over there, which you can't see, would look like this. The front would be on this side, which is a side you can't see. The right side, you would stick here. The left side, you would stick here and be about that big. And then, do I have any room here? And then the bottom would be the same rectangle as that right there. Do I have a box I can just look at for sure? Who needs the tissues anyways? Had this thing been taped together, I got scissors right on right now. Hannah, why don't you grab a pair of scissors and run really fast with the point up? Just kidding. Oh, what college got right here? Forget it. Forget it. So here's my box. Okay, if I were to cut, this is what we call the net of it. If I gave somebody a box of tissues for Christmas,
That's an epic present.
it wouldn't be a bad present if you had one of those all the time.
It would be an epic present, but the person had no value.
We're not worried about the president. He can buy his own tissues.
Not a true story of Christmas.
If you took this box,
Obama's too good to go out by Christmas. Like,
if you took your box of tissues, so there you go. Unfortunately, this side over here came apart, so I couldn't do it. So there is this is my net of that. I really wanna find the area of this so I can buy some wrapping paper so I can wrap it appropriately. Okay, so in order to do this, I have to find the area of all the sides. So let's say this is 10 inches, and this is 6 inches, and this is 3 inches. You are going to need to find the area of at least 3 different shapes. Because the front and the back are exactly alike, here's the rectangle that would be the front. The front is 2 inches by 3 inches. And what would be the area of the front? 10 times 3 is? Yes, 30 inches, square inches. There we go. And the back would be the exact same shape, so you can just put down 2 30s right away. The right side is the same height, but it's a smaller sort of rectangle. It's only 3 by 6, so its area is 18 inches squared. And the left side is the same exact rectangle. And then on the top and the bottom, those are the biggest rectangles. So that is 10 by 6. And that is 60 inches squared. Both the top and the bottom. So the total surface area, TSA, is 30 plus 30 is 60, 78, what is that? 896, 156, 316 inches squared. If you add all that together, I hope you get 360. If not, I did something wrong, but I was just kind of running out of room there. Did I do it right? 120 plus 60 plus 36.
156.
I'm sure. What?
I think it's 156.
I think it's 216. How about 216? I just added 3. 6 to 1/2 dozen the other. But that's what you need to show when you talk about surface area. Okay? You've got all of the sides added together. Sometimes the shapes aren't quite as nice as a rectangular prism. There's one in the book there. But the other thing we have to talk about is, and I suppose you should write this on a whole separate piece of paper because it starts with a different letter, the lateral surface area. And the lateral surface area is very much similar. It is surface area, but it is only the surface area of the sides. You exclude the top and the bottom. And I guess an example of that would be if I asked you, here's my question to you, if I said, how much paint would be needed to paint the walls of my classroom? You would use the lateral surface area. Why? Because I don't need to paint the ceiling, which is the top, and I don't need to paint the floor, which is the bottom. I only want to paint the walls, and that would be the lateral surface area. So let's actually do that problem. Here's my classroom. Which wall should this be? Let's make that a chalkboard wall. So then we'll come out like this, come out like this. I don't know if anybody can see this coming, but I think I've got it. Here's my chalkboard over there. So in order to figure out how much paint I'm going to need, I'm going to say my ceilings are probably 9 feet tall. And we know my room is actually a 30 by 30. So to find the lateral surface area here, I can just do the front and the back and the right side and the left side. Get those areas. The front we know is what, 30 by 9, which happens to be 270 feet squared. The back's going to be the same exact thing. The front, or the left side and the right side, is what, 30 by 9? Actually, they're all going to be exactly the same, aren't they? I just didn't draw a very good picture there. So my lateral surface area is 270 plus 270 plus 270 plus 270. Somebody should be able to do that. If these were all 250s, it'd be 1,000, right? Because each one is 20 more. So it'd be, Lucas?
1,000.
Could just wait till I write it down. 1,080 feet squared. Okay, lateral surface area is everything but the top and the bottom. Now, I'm going to help you out with this here. A problem right out of the book is this problem. If you look at page 295, we've got a shape that looks like this. Anybody getting better at drawing some of these three-dimensional things?
No.
That's 12, 12, 15, 20. 12, 12. Did I really mess that up? Yeah, 15, 20. Still under lateral surface area, children. I'm going to help you out here. If I was trying to find the lateral surface area of this shape here, how many different sides would I have to find the area of? It's the area of all the sides except this top and this bottom that you can't see. How many different sides? Remember, there's a dashed line here with a line that goes like this, and that dashed line goes there with that line here. How many different shapes make up the sides of this thing here? You've got this one, let me do it in yellow colors here. You've got this one, you've got this one, you've got this one, you've got this one, you got this back here that you can't see, and you've got this side here. That's all the sides except the top and the bottom, and that's how many sides?
6.
Is that 6? 1, 2, 3, 4, 5, 6. Okay. There is an actual formula for lateral surface area that will save you a little bit of time. Okay, and this is what you should write down for this. Lateral surface area, instead of having to do this, which you could do, by the way, lateral surface area also equals the perimeter of the base times its height. I mean, maybe I can get you to see why that is. Maybe I can get you to see why that is. Let's just break this apart a little bit here into the shapes that I'd have to find the area. If I was going to do it the long way, I've got this shape right here, right? That looks like this. And what is its dimensions? 10 by 12, right? I've got this shape right here, which is this dimension. It is what? Still 10 high, and 12, right? I've got this shape right here, which is 15 by 10. I've got this shape right here, which is 20 by 10. I've got this shape back here, which is, what's this long distance from here to here? 12 plus 15, it'd actually be 27 times 10. And then I got this side over here, which is 20 plus that, 32 times 10. What do you notice about every one of those shapes? Corinne? Right, they all have a height of 10, which is where this number comes from. Okay? That's all, every one of them has the same height because that's the height of the shape. And to get the perimeter of the base means that you're taking all of these numbers, this 12 plus this 12 plus this 12 plus this 12 plus this 15 plus this 20 plus this side over here, which is the 32, plus that side over there, which was the 27, or vice versa. Okay, if you add the whole perimeter together and then multiply by 10, it's the same thing as doing each side by 10. So all you have to do is add this 12 plus 15 plus 20 plus 27 plus 32, get that number, and then just multiply it once times the height. It's like multiplying them all by the height. Just accept it and enjoy it. So the only thing I need to do on this is take my 12, my 15, my 20, that gets me to here. This distance here was that 27, and this distance here is that 32. This is my perimeter of this shape. You take the perimeter of this base type shape, and multiply it by, get that whole answer, multiply it by 10, that's the same thing as doing each one of these separately and multiplying it by 10. Mrs. Nolan?
Which way do these go in here?
Ooh, that's a good question. It comes upside down, so right side up.
Right side up?
No, that's my phone. It's a little tray right underneath there. Yeah, pull that back, pull it out.
Right side up.
Because it comes out upside down. So if they ask you for lateral surface area, 7th grade, all you need to do is find the perimeter of the base and multiply it by the height, rather than doing each separate shape, which will take you a lot longer and maybe you could get messed up a little bit more. Let me see if I can find an example of that for you. Look at page 297. 297. If you run across this first problem, practice set A, where it says, what is the lateral surface area of a tissue box, oh my gosh, with the dimensions shown? What's the first thing you should do, Nikki Cowell?
Find the dimensions of the.
Draw
Oh, yeah.
the box on your paper.
Find.
I know you did, I was just testing you. And what is it? It's 4 by 5 by 9. And they want the lateral surface area. So the next thing you would do is write down the formula, which is perimeter of base times the height. So let's break this down here, Sage Hive. What is the height of this shape? 4. Thank you. Wow, well done. Now we just need to find the perimeter of the base. So what is the perimeter? It's going to be 9 plus, what's this? 5 plus 9 plus 5. What is 9 plus 5 plus 9 plus 5? Nathaniel Lick says
And cheese.
28. That Nathaniel Lick, if I could just hear him show his work, he would be a stellar.
I showed him.
So the lateral surface area is 4 times 28, which is 112. And since it's an area, what is the label? Inches squared or square inches. Again, so be careful with that. If it would ask me for total surface area, what else do I have to add to that? Lucas?
Top and bottom.
Right, you'd have to find the area of the top, which was 45, and the bottom, which was 45. Add those together, and you've got the total surface area.